This is my 9 cm ATV transmitter. Some of you will recognize the housing. In fact, this is the back of a small monitor. On the front I made a new plate, and it has originally the cathode ray tube, the image tube here, but now it is a transmitter. Let's open it. And this is inside. And it also shows why the cabinet needed to be so large. This is a heavy power supply, 12 volt, because this amplifier module, the purple one, has a lot of gain, but it takes also a lot of current, more than 10 amps at 12 volt DC, so it already takes a large amount of space. And this amplifier is also warming up, so I added a small fan here, so it makes some noise. And in fact, what it all is, it is a fixed frequency transmitter. The frequency is generated in this housing. Just some explanation about the circuit that generates 1/3 of the final frequency. We have an oscillator here that's running around 1100 megahertz, and it's amplified by an MMIC, and some energy is taken to this SP5060. At that time, we're talking about 1987, the schematic is so old, it is a PLL that divides the frequency by 256, and that signal is locked to a crystal here, and in this case I could take a PAL color burst crystal, so 4.433 megahertz, and that's locked, and the output, the difference, is here as a DC voltage going back to the oscillator. It's a voltage controlled oscillator, so if it deviates from this 4.433 multiplied by 256, then it will be here corrected, so the frequency is stable. And the video is also connected to the VCO here, to the Varicap diode, so you modulate it with FM, and the signal goes via this coax cable to a multiplier. It multiplies by 3, and with FM you can multiply the frequency. I use this board made by Frans P1FOT, and it contains 2 MMICs, one here and one here, with their own voltage regulators, and a stripline filter that passes a few hundred megahertz around this 3.4 gigahertz band. So it only takes the third harmonic that is generated here. Because we only needed -6 dBm for the final amplifier to have 20 watt output, I made a small potentiometer here to adjust the output power, so the output power is very low. And then it goes to the power module. And what we see here is, can you see it? What we see here is a video filter. A normal video spectrum contains all this kind of signals here till 5 megahertz, and in this case I added a few components as a low pass filter, and it cuts everything behind a few hundred kilohertz completely off. So this is the video spectrum that we offer to the transmitter to have from this without the filter, finally this with the filter. On the HF spectrum
because the band is only 10 MHz wide.
This is the video input and it goes to the video filter, and there's also some DC output coming from the amplifier that goes to this meter that shows if it functions or not.
If you found this video interesting, a subscription is highly appreciated, and also of course a thumb up. Hopefully till the next time, see you.